Good morning, students. Welcome to Brilliant Public School. The topic for the day is Concepts of Three-Dimensional Geometry for Class 12th Mathematics. For that, let us first recall few things which we have learnt in the previous chapter, Vector Algebra. Angles alpha, beta and gamma made by position vectors OP with x, y and z axis respectively are called as directional angles. The cosine values of these angles, that is cos alpha, cos beta, cos gamma, are called as direction cosines and are defined as cos alpha is equals to x by r, cos beta is equals to y by r, cos gamma is equals to z by r, where r is the magnitude of position vector and defined as r is equals to xi plus yj plus zk, that is r is equals to under root of x square plus y square plus z square. Now let us understand what are direction ratios of the line. If A, B, C are the direction ratios of the line, then L upon A, which is equals to M upon B, is equals to N upon C. If A, B, C are the direction ratios of the line, then direction cosines are given by L is equals to plus minus A upon under root of A square plus B square plus C square. M is equals to plus minus B upon under root of A square plus B square plus C square. And N is equals to plus minus C upon under root of A square plus B square plus C square. So direction ratios are the numbers which are proportional to the direction cosines of the line, and if L, M, N are direction cosines of and A, B, C are the direction ratios of the line, then as earlier discussed, we have this relation between L, M, N and A, B, C. Direction cosines of a line passing through 2 points. Consider 2 points P and Q as shown in the figure and let L, M and N be the direction cosines of the line PQ, and let it make angles alpha, beta and gamma with x, y and z axis respectively. So, the direction cosines of the line passing through 2 points, that is P x1, y1, z1 and Q x2, y2, z2 are x2 minus x1 upon PQ, y2 minus y1 upon PQ and z2 minus z1 upon PQ, where PQ by distance formula is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now let us come to the topic equation of line in space. In three-dimensional space, a line is said to be uniquely determined if it passes through a given point and has given direction, or it passes through the given 2 points. Now let us see the equation of a line through a given point and parallel to the given vector. As shown in the figure, let A be the position vector of the given point A with respect to origin O, and let L be the line passing through A and is parallel to vector B. Let R be the position vector of arbitrary point P on the line. So, vector equation of this line passing through a point with position vector A and parallel to vector B is vector R is equals to vector A plus lambda vector B. The Cartesian equation of this line is given by x minus x1 upon A, which is equals to y minus y1 upon B, which is equals to z minus z1 upon C. You know that A, B, C and LMN are proportional. So, if LMN are the direction cosines of the line, the equation of the line can also be written in the form of x minus x1 upon L, which is equals to y minus y1 upon M, which is equals to z minus z1 upon N. Now let us see what is equation of line passing through the two given points. Means we have the knowledge of 2 points. So let A be x1, y1, z1 and B be x2, y2, z2. Position vector of a point A, it is equal to xi, x1i plus y1j plus z1k. Similarly, you can see what is the position vector of B. Normal vector of line be n, which is B minus A. So equation of this line is given by vector r is equal to vector a plus lambda times vector b minus vector a. Cartesian form of the line passing through these two given point is x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, which is equal to z minus z1 upon z2 minus z1. Now let us come to angle between two lines. Let theta be the angle between two lines whose direction cosines are L1 M1 N1 and L2 M2 N2 respectively. Now the angle is given by cos theta is equals to L1 L2 plus M1 M2 plus N1 N2 if the direction ratios of the two lines are A1 B1 C1 and A2 B2 C2, then the angle between these two lines is given by cos theta is equals to A1 A2 plus B1 B2 plus C1 C2 upon under root of A1 square plus B1 square plus C1 square into under root of A2 square plus B2 square plus C2 square. Now let us come to the special cases. If the lines are perpendicular, then A1 A2 plus B1 B2 plus C1 C2 will be equal to 0 because you know that cos 90 is 0. And if the lines are parallel, that is theta is equals to 0, then we have A1 upon A2 is equals to B1 upon B2, which is equals to C1 upon C2. Now, the next topic in this chapter is skew lines. What are skew lines? Skew lines are the lines in space which are neither parallel nor intersecting. That is, they lie in different plane. The shortest distance between the skew lines L1 and L2 with equations r is equals to a1 plus lambda b1 and r is equals to a2 plus mu b2 are given by the vector equation D is equals to mod of b1 cross b2 dot a2 minus a1 upon b1 cross b2, and the equation in Cartesian form is given as shown in the figure. Now distance between two parallel lines with vector equations r is equals to a1 plus lambda b and r is equals to a2 plus mu b is given by mod of vector b cross a2 minus a1 upon mod of vector b. Now let us discuss the things about plane. The plane is uniquely determined if the normal to the plane and its distance from the origin is given. Second, it passes through the given point and perpendicular to the given direction. And third, it passes through three given non-collinear points. Now let us see the equation of plane in normal form. You can see it in the figure that we are considering an arbitrary point xyz with position vector r, and d is the distance of the plane. Now vector equation of a place at a distance d from the origin and normal to the vector n is vector r dot n is equals to d, where n is the normal vector. Cartesian equation is given by Lx plus My plus Nz is equal to D. Now equation of plane passing through three non-collinear points is given by vector r minus a dot vector b minus a cross c minus a, which is equal to 0. The Cartesian form of the same equation is given in the determinant form, that is x minus x1, y minus y1, z minus z1, and respectively with x1 and x2 and x1 and x3, and the determinant is given as equal to 0. This is the Cartesian form of a plane passing through three non-collinear points. Now let us see what are the plane passing through the intersection of two given planes. Let us see the equation of this. Now if I have two planes as shown in the figure, say pi 1 and pi 2, and pi 3 is the plane which is passing through this, then the vector equation of a plane passing through the intersection of the plane r dot n1 is equals to d1 and r dot n2 is equals to d2, and also through the point x1 y1 z1 is r dot n1 plus lambda n2 is equals to d1 plus lambda d2. Equation of a plane passing through the intersection of the planes a1x plus b1 by plus c1z is equals to d1 and a2x plus b2y plus c2z is equals to d2 is given as a1x plus b1y plus c1z minus d1 plus lambda into a2x plus b2y plus c2z minus d2 is equal to 0. Now, last topic of this point, distance of a point from a plane. Equation of a plane is given by r minus a dot n is equals to 0. The distance is from the point x1, y1, z1 to the plane ax plus by plus cz plus d is equals to 0 is mod of ax1 plus by1 plus cz1 plus d, which is upon under root of a square plus b square plus c square. Let us have a quick recap about the things which we have discussed in this video. Equations of line in vector form and Cartesian form, equations of intersection of line and plane, equations of intersections of two planes and a line, and angle between two lines. These are all concepts which are there in the chapter 3-dimensional geometry of class 12. You need to keep practicing by solving questions based on these concepts. Keep learning. Thank you everyone.